Welcome those who are watching my video. This is the introduction part of chapter number 1, relation and function. These are the topics that you have learned in class 11. Now let us start. Set. What is a set? A well-defined collection of distinct objects is called a set. There are two ways of describing a set. Number 1, roster, set roster or set tabular form. Number 2, set builder or rule form. These are the set roster or tabular form. These are the elements are separated by commas and within the curly bracket. These sets are in roster or tabular form. And number 2, x says that x is a natural number and x is less than 4. This set is in the form of set builder or rule form. I hope you understand. Next, subset. What is subset? A set A is said to be a subset of a set B if every element of A is also an element of B. For example, let the set A is equal to 1, 2, 3 and the set B is equal to 1, 2, 3, 4, 5. Then all the elements of set A are included in set B. That is why we can say A is a subset of B. I hope it's clear. Then what is Cartesian product? Set of all order pairs are called Cartesian product. For example, let A is equal to 1, 2 and set B is equal to 3, 4. And if we want to find out A cross B, that means Cartesian product. A and read as A cross B is equal to, what is the value of A? 1, 2 cross 3, 4. Then if we find out, if we want to find out A cross B, then 1, 3, 1, 4, 2, 3, 2, 4. These are the all order pairs. This is called Cartesian product. I hope you understand. Then let's come to the syllabus. Number 1, relation in a set. What is relation in a set? A relation R in a set A is a subset of A cross A. Relation is a subset of A cross A, and we have understand that what is A cross A. That means this is the Cartesian product. For example, let A is equal to 1, 2, 3. Then if we want to make a relation, R is equal to 1, 2, 2, 3, and let us say the order pair 1, 2 and 2, 3 is included in A cross A. And if we find out A cross A, this is the elements of A cross elements of A. And if we want to find out A cross A, then 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3, 3, 1, 3, 2, 3, 3. These are the Cartesian product of A cross A. These are the Cartesian product of A and A. That means A cross A. If the order pair 1, 2 and 2, 3, 1, 2, 2, 3 here, this is the subset of these order pairs are included in A cross A. Therefore, this is a subset of A cross A. Therefore, it is a relation. And we know that relation in a set A is a subset of A cross A. If the relation is a subset of A cross A, then it is a relation. Hope you understand. Then, what is empty relation? A relation R in a set A is called empty relation if no element of A is related to any element of A. That is, R is equal to phi is a subset of A cross A, and we know that phi is a subset of A cross A. Phi is a subset of every element. For example, let A is equal to 1, 2, 3, 4. These are the set. These are the elements of set A. Then let us make a relation, empty relation. R is equal to AB, the set of all order pairs represented by AB, such that A minus B is equal to 10. And if we take any two elements and subtract, then we cannot get 10. That means if we want to take 2 minus 1, then 1, 1, 10. Then the order pair 1, 10 will not be found in A cross A. If we find out A cross A, then the order pairs will not be fine. Some order pairs will not be fine. That is why this is the empty relation. I hope you understand. And let us take another example. Let A is equal to 1, 2, 3, 4, 5. And R is equal to xy, set of all order pairs. And such that y is greater than x plus 5, xy belongs to set A. And if we take any element from set A. Let us take 1. 1 plus 5 is equal to 6. 6, 1 and 6. The order pair 1, 6 is not included in A cross A. If we find out A cross A, 1, 6 is not included. That is why let us take another example. If we take 2, 2 plus 7, 2, 7. That means if we take 2, then the value of y is 7. 2, 7 is not included in A cross A. That is why this relation is empty relation. I hope you understand. Then universal relation. A relation R in a set A is called universal relation if its element of A is related to every element of A. That is, R is equal to A cross A. If the relation is equal to A cross A, then the relation is called universal relation. Now let us take an example. Let A is equal to 1, 2. And if we find out A cross A, and the relation R is equal to 1, 1, 1, 2, 2, 1, 2, 2. If the relation R is equal to A cross A, if we find A cross A, then the relation equals. Therefore, this relation is called universal relation. I hope you understand. Then, next, what is trivial relation? Both empty relation and universal relation are sometimes called trivial relation. Then, reflexive relation. A relation R in a set A is called a reflexive if and only if A is related to A for every A belongs to A. And we can write as A is related to A, same as A belongs to A. We can write as like this instead of this. And let us take an example. Let's see the example. Let A is equal to 1, 2, 3, and let R is equal to 1, 1, 2, 2, 3, 3. These are the this relation is empty relation, reflexive relation, because all the elements in A are related to itself. That is, 1 is related to 1, 2 is related to 2, 3 is related to 3. If one element is left which is not related to itself, then that relation is not reflexive relation. All the elements in the set should be related to itself, because here in the definition, A is related to A for every A belongs to A. That means all elements in A should be related to itself. I hope it's clear. Then, symmetric relation. What is symmetric relation? A relation R in a set A is called symmetric relation if A is related to B implies that B is related to A for every A B belongs to A. And we can write another form. A B belongs to R. We can read as A is related to B. Implies that B is related to A. We can write like this also. B is related to A. We can write like this also. So for every A is related to B, there should be B belongs to A. That means if 1, 2 is there, 2, 1 should be there. And 2, 2 is there, 2, 2 should be there here. All the elements for every A B belongs to A is related to B, there should be B belongs to A. That means if there is 1, 2, then there should be 2, 1 should be belongs to in the relation. I hope it's clear. Then let's go to transitive relation. A relation R in a set A is called a transitive relation if A is related to B and B is related to C. Implies that A is related to C for every A B C belongs to A. Now let us take an example. Let A is equal to 1, 2, 3. R is equal to 1, 1, 2, 2, 3, 3. And if we take if A is related to B and B is related to C, and there should be compulsory A is related to C. That means this is 1, 1. That means AB. There is not 1 and BC. That means there is not BC. If there is not BC, then that is also transitive. 1 to AB, that means there is not BC. If there is BC, then A should be related to C. So we can take another example also, R1. That means if there is 1, 2, if there is 1, 2, then this is AB, and another one is 2, 3. AB, then BC. BC is there, then compulsory A should be related to C. That means 1, 3 should be included. I hope it's clear. If there is A is related to B and B is related to C, then A is related to C should be compulsorily related. Otherwise, that is not transitive relation. And the last one is, what is equivalence relation? What is equivalence relation? A relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric, and transitive. The relation should be reflexive, symmetric, and transitive in order to become equivalent relation. Now let us take an example. Let A is equal to 1, 2, 3. Then the relation R is equal to 1, 1, 2, 2, 3, 3. All the elements in the set A are related to itself. That means 1 is related to 1, 2 is related to 2, 3 is related to 3. Therefore, this is reflexive. Then it is also symmetric. That means 1, 1 is there, 1, 1 is there. 2, 2 is there, 2, 2 is also there. 3, 3 is also is there. That means A is related to B, B is also related to A. Therefore, this relation is also symmetric relation. Then last one is if there is A is related to B, not B is related to C. A is related to B, A is related to B, but B is not related to C. If there is B is related to C, then A should be related to C is compulsory. Here the theory of exercise 1.1 is completed. I will bring the next video of the solution of exercise 1.1. Until then, bye. Thank you for watching my video. If you like my video, please like, subscribe and share my video. Thank you.